First analysis we'll look at then is shadow analysis. Here we have a building and we can see the shadows cast around it. What I can do is interactively update those shadows by changing the time of day like so, or also coming in and changing the time of year. I could also overlay a sun path. So what I've got here is my sun path. I can just drag the position of the sun. Again, I see the shadow position update. Or I could change that to the annual sun path. And what I can do by holding down the shift key is simply change the time of year. It's also possible for me to take a look at that building inside. So here again we have the interior of the building and the shadows are cast within it. So just changing the time of day here, we're seeing the movement of shadows into that space, giving us a really good understanding of the feeling within that space. We could also animate that as well. So a really powerful tool for analysing the shadows. Let's move on and look at another example of shadows, which is actually with a cityscape. So if I'm doing some urban planning, what I may have is my development and I want to understand the shadows that are being cast by my development. Here I'm able to show just the shadows from my particular development and I'm able to choose the colour in which I want them to be depicted. I could show all of the shadows for all of the buildings as I'm seeing here. Very powerful tool in giving me an understanding of where my building is adding to the shadowing, and I can take that even further by simply doing a reverse sort, and what we now see is the specific areas where my building is adding to the overshadowing. And what I'm going to do now is just switch over to the Visualize tab, hit the plan view, and what I can also demonstrate is that I can show a range of shadows throughout a course of a day. So I can specify the start time in the day and the end time, and what we're seeing there really is the butterfly diagram effect. Let's now look at how Ecotect analysis can be used to optimize shading device designs. So what I've got here is a window that I've just selected, and what I'd like to do is create a device optimized to protect that against sunlight. So I'm going to come up to my Calculate pull-down menu and select my Shading Design Wizard. And as with many of the analyses within Ecotect, it's wizard based. It steps me through the process to get the result I require. So I have various options there. I can choose, for example, the time of year or the hours of the day that I want to help protect against. And I can choose the optimum size that or shape that I require. Just select OK there, and what you'll see is it's generated a shading device for me that's going to protect that window. If we just switch over to the Visualize tab here and just select Display Shadows and just simply change the time, we can see how that device is protecting that window against sunlight and shading it effectively. Let's move on then and look at another area of Ecotect analysis that we can use for shading device design. And this is where we have the ability to actually show the rays from the sun. So with Ecotect we don't need the whole building to perform analysis. As you can see here, we just have a small part of it. But what I've got here is a light shelf as part of a facade system, and I want to try and understand how effective that light shelf is at bouncing light into the space. As we did with shadowing, it's very simple to update the position of the rays by changing the time of day, or of course changing the time of year, so we can really start to understand what's going on within that space. What you'll notice from this example, if we just change to the side view here, and I'm just going to change that to say May, it's not a very effective light shelf. It's literally bouncing the light off of the light shelf and illuminating the outside of the building. So what I would need to do is perhaps change that design, change the position. But Ecotect analysis is really making that easier for me to do. Let's now explore some solar radiation analysis. What you're seeing in front of you is the real key benefit of Autodesk Ecotect analysis, and that's the ability to portray what can be quite complex analysis results in a very digestible manner. It's very visual. We can see from the differences in the colours that there are different levels of radiation falling on different facades. It makes it very easy for us to use that as a basis to start implementing certain facade strategies. So I can also use that in my conversations with clients and other members of the design team. Very important, especially when you're in value engineering meetings. So how do we get to that result? So let's walk through another model and actually perform a calculation. And again, what we're going to do is run through a wizard. So just selecting my solar axis analysis wizard. I've got some various types of solar axis analysis that I can perform. I want to see the incident solar radiation. I can step through, I can pick particular time periods, change the time of day, or using the pull down, select a particular time of year. So let's do it for winter. And the type of results that I want to see, averages, peaks, cumulative values, for example. and just going to step through that. It will now perform the calculation. It's very quick on this occasion because it's already done one iteration, and what we can see now is we've got some results here. So we can use this as the basis for making a decision on, say, embedding photovoltaic panels into the curtain walling. This is the winter results. We use a lot more energy in winter, so we want to try and use renewable sources for that. So what we can see on this facade here that's more golden in colour, we can get more energy using that facade with photovoltaic panels than on some of the others, which quite honestly are not going to give you that much return if you're using that for particularly harnessing it in winter. So a very, very powerful tool in informing our decisions. Let's look at another way of portraying that radiation. So here what I've got is a stadium. So before we saw that shown onto objects in the model, and here what we have is it shown onto an analysis grid. And we're seeing here that certain levels of radiation are falling onto that. And we could start to use that. We could use that to help us promote grass growth by harnessing the levels of daylight, of sunlight onto that. And we could also take that a step further, and using a more advanced Ecotect analysis, what we can do here is use a slider bar to actually optimize the size of that glazing. So we know where the majority of radiation is falling, and we want to take advantage of that, but we also want to balance that up against the amount of overshadowing, which would of course prevent grass growth. Let's now look at daylighting analysis within Autodesk Ecotect analysis. Daylighting is an important factor in ensuring the comfort of occupants and their well-being, but also for reducing energy. If you can make use of natural daylight, you're less reliant on powered light sources. So let's take a look at this building here and some of the results for light levels within an atrium space. So what I'm going to do is just turn off the surfaces, and here what we can see is an analysis grid. What we're able to do with that is change the position of that grid so that we can see the difference in light levels throughout the atrium. But if it makes it easier, we can also turn on something called volumetric rendering. So what we can see here now is in a three-dimensional rendered form the actual light levels within that space. Really helps us to understand that better. But what I can also do is actually look at some different options. So by tying analysis results to different geometry, I can step through different options and really understand their impact on the sustainability of the building. Let's look at some other areas of daylighting then. And what I'm going to do now is just open up another model here. So what I've got here is daylight factor in a dynamic model. What I'm going to do is change the size of openings and see the impact on the daylight factor. Before I do that, I'm just going to turn off the volumetric rendering. So what we've got here is a building, and we've got some various glazing around that. What we're able to do, if I just change the position of this slider now, what you can see is that it's changing the percentage of glazing across the space. So what I can do now, if I just switch to a wireframe view, is see the impact of changing that glazing on the actual daylight factor within the space. So I can get a compromise between how much daylight I'm using and how much glazing I'm using. Very, very powerful use of the tool. We can also take that further as well, and we can use a script to actually specify a target daylight factor for a specific room. So what I'm going to do here is just enter a daylight factor of 6%, like so, and what you'll see is it's going to do some iterations, change the size of the glazing, but based on hitting a daylight factor of 6%, and I could also do that vertically as well. Okay, so another important aspect of daylighting is not taking away daylight from neighbouring buildings with a new development. An advanced feature of Ecotect analysis is to use the scripting engine to help generate form. So what I can do here is set a script running, and what this is going to do is generate the form, stepping back the mass to ensure that we're not taking daylight away from those neighbouring windows. Again, a really useful function for using an analysis tool to drive design. Also, if I'm looking at right to light issues, I can generate extrusion planes. So I can see here, using the Building Research Establishment's guidelines, a vector of 25 degrees from a particular window. Anything above that is going to actually start to impede on the daylight within my building. So another way of trying to understand the impact of a development on daylighting.